Hey everyone, in this video you will learn how to draw a cycloid given the radius of a rolling circle and a point P on its circumference. Okay, so here we have our circle and the radius of our circle is 50 millimeters, and what I'm doing now is I'm just dividing one quadrant of the circle into three parts, which would be angles of 30 degrees. So our first angle was 30 and our second line would have an angle of 60, but between each line there's an angle of 30 degrees. So here we have our first quadrant, and I'm not gonna go ahead and draw all these lines individually. I'm going to mirror them like this, and just to save time. Now, of course, if you're doing this manually, you will have to draw each line individually and so on, or you may just use your set square and draw both sides of the diameter at the same time. Right, so we have our circle fully divided into 12 parts, and off camera I have numbered the parts or the lines, so they are numbered 1 to 11, and then there's P at the base. So that's the point that we will be tracking in order to create the cycloid. Also, you'll see line P12, and line P12 is equal in distance to the circumference of our circle. Now we want to divide line P12 into 12 equal parts. So what I'm going to do right now is a construction that I've shown many times on the channel that we use to divide a line, or to dissect with a D for dog, to dissect a line into equal parts. So I'm drawing some arcs here. They are equidistant from each other. I'm just copying them, and we need 12 of these. So I'm gonna cut the video, and when we come back we will have 12 just like this. Good. So off camera I would have drawn 12 of them, and their distance from each other is the same, and now we are going to complete the dissection of line P12 by drawing these parallel lines. Again, I have explained this construction before in several videos, but I will link the original explainer video below. Okay, so off camera we would have drawn all the parallel lines, and I would have trimmed them so that it looks neat. And here we have 1 to 12, they are numbered, and each line is the same distance from the other, or you can say they are equidistant. What we are going to do now is we are going to create a rectangle. Yeah, so I just copied line P12, and now we will enclose our rectangle. What's going to happen next is we are going to draw vertical lines from each point on P12, and also from our circle we are going to draw horizontal lines from each point on the circumference. So you can see me here pulling a horizontal line from point 1. I'll do the same for points 2, 3, 4, and 5. Point 6 is already there, it's the top of the rectangle. As usual, if you are having trouble following or keeping up with the instructions or what you have to do, feel free to slow down the video or rewind it and go back and make sure you understand. So now we are copying our external line. All these lines are the same height, so I can use it repeatedly. And these steps are very necessary in order to successfully plot our cycloid. Right, so now we have a grid, a rectangular grid of sorts, and this grid is very important. It's extremely important. If you are lost, if you got to this point and you're not sure how we got here, feel free to go back and watch it again. Okay, so what we're gonna do now is each line, each vertical line, so line 1, 2, 3, 4, 5, etc., will be used as the basis for our center. We're going to use the horizontal line 3, 9, as you can see here. So wherever 3, 9 intersects with vertical line 1 or vertical line 2 or vertical line 3, that point will be the center for our compass, or the center for our arc if you are doing it via CAD like I am. So let's go. So our radius is the radius of the circle, so it's 50. And the center for this arc is vertical line 1, where it intersects with horizontal line 9, 3. So we are drawing an arc to cut horizontal line 111, as you can see. Alright, it might sound very confusing, but if you slow it down, you'll get it. So where the arc cuts horizontal line 111, that is P1. Now we're going to draw a second arc. So we're using vertical line 2, and where it intersects with horizontal line 9, 3, which is right here, we're going to draw an arc with a radius of 50 to cut horizontal line 2, 10 or 10, 2. So that's what we are doing right now, and this point will be P2. So these points we are establishing are there for us to plot the cycloid, basically. So this is P2 and this is P1. So P1 was vertical line 1 intersected with line 9, 3. Then we drew the arc to cut line 111. Let's go to vertical line 3, where it intersects with horizontal line 9, 3. We're going to draw a line with a radius of 50. 50 because that's the radius of our circle, and we want this line to cut horizontal line 9, 3, just like this. Of course, you may have guessed this point will be P3. Alright, so the steps continue. So next, of course, we're going to go over to vertical line 4, and where it intersects with horizontal line 9, 3. We're going to draw an arc to cut horizontal line 4, 8. And that would be P4. Right, so it's it's the same thing over and over until you get to vertical line 6, and then you start going down on the other side. Okay, so because of time, I would have cut out me drawing P4, P5, and P6, but the procedure is the same. It's pretty repetitive, right? And now we are going to do the other side. We're going to do P7, P8, P9, etc. Of course, for P7, we'll use vertical line 7, and where it intersects with horizontal line 9, 3, we're going to draw an arc with a radius of 50 so that it cuts horizontal line 7, 5. So there we have it. And where the arc cuts the line, that would be P7. Now all these points, as I would have said earlier, all these points are extremely important in order for us to get the correct answer. Okay, so off camera I did P8, P9, P10 and P11 because they are all, it's the same thing. And 12.12, or 12 will be P12. That's the end of the cycloid. So now that we have all the points that we need, we're going to go ahead and plot the points or draw the cycloid using the spline command in AutoCAD. If you are doing it manually, then you can use your French curves, or you can just do it freehand if you are skillful enough. So the objective here is to get all the way to all the points, all the P points. So P1 to 6, and now we are coming back down on the other side, P7 to 12. Alright, so this is P11 and we will end at 12. You enter it and that's it. This is your cycloid. All that construction, all those lines was just to get this curved line. Of course, I'm going to change the layer so that it stands out a bit more. So this is it. This is the cycloid that is formed when point P rotates, or when the wheel or the circle rotates, and point P, this is the path that point P will take. I've gone ahead and darkened the outline of the circle so that it's easier to see, but this is it. I trust that you would have learned. Please like and subscribe if you haven't already, and thank you very much.
That's big.